This is the third part of our lesson on solving polynomial equations. So in our previous example, we looked at how to use the quadratic formula, which was some review from grade 10 and grade 11. So the quadratic formula works on things that are in the form ax squared plus bx plus c, if it's a quadratic, right? So if something's a quadratic, the highest exponent is a power of 2. But the quadratic formula actually works on things that aren't just quadratics. So as long as that first exponent is double the second one, you actually can still use quadratic formula with a little twist. So it's just like factoring by decomposition. As long as the powers that you have, right, the first exponent is double the second exponent, and then the third number is a constant, you can still use quadratic formula. So, I tried to refocus and it didn't like that. Nope, let's try putting this down. There we go. Okay, so I have x to the 6 minus 18x cubed plus 13 equals 0. So I notice that this exponent is double this one, so I should still be able to use quadratic formula. I want to make sure that it equals 0, otherwise we can't really solve. And it tells me to round my final answers to 2 decimal places, which means I'm going to be able to use my calculator to actually calculate my final answers. So I'm going to write down the quadratic formula to start. So it is x equals negative b plus or minus square root, and I don't know about you, but I always sing the song in my head when I do this, minus 4ac, oops, I think I forgot to say b squared minus 4ac, and then divided by 2a, right? So a is the number in front of the x to the 6. That's going to be a secret 1. B is going to be the number in front of my x cubed, and c is going to be the constant, or just the number that's by itself. So if I substitute things in, there's something I need to talk about first. This is the quadratic formula, right? X equals negative b plus or minus square root b squared minus 4ac over 2a, which works when it's a quadratic. But this isn't a quadratic. This actually has a degree of 6, which makes it a sextic. So I have to modify the formula if I want this to work. So when I look back at this previous example, you'll notice we were solving for x. X is what is on my middle term, right? I have an x here on my middle term. We were solving for x. When I'm solving with this one, because the exponents are higher, we're not actually going to get x when we do this calculation. We are going to get what our middle term is, which is x cubed. So this should have a power of 3 on it. If we were solving, just going to grab a Post-it note. These ones actually have grids on them. If I had x to the 4 and then x squared and then a number, when I'm using quadratic formula, I would be solving for x squared, right? If we had x to the 10 plus x to the 5 and then a number, when I went to use the quadratic formula, we wouldn't start with x, we would start with x to the 5. We want to match what's in the middle of our equation. So for this one, because this is a higher exponent, we're not solving for x, we're solving for x cubed. So this is going to be x cubed equals negative b. Now b is negative 18, so negative 18 actually makes positive 18. So it just changes the sign. And then that's plus or minus the square root of b squared, so negative 18 in a bracket squared. If you don't do the bracket, your calculator might not give you the right answer. And then minus 4 times a, which is a secret 1, times c, which is 13. And then that is all divided by 2, and then a, which is 1. So just like last time, I'm going to evaluate everything underneath the square root and simplify my denominator. So I have x cubed is 18 plus or minus the square root of, now negative 18 squared minus 4 times 1 times 13, I get 272. And then 2 times 1, that's 2. Does 272 have a nice square root? Unfortunately not. If it did, I would work it out, so if it worked out evenly. But this, unfortunately, is a decimal, so I'm going to hold off on that for a second. Since it didn't work out nicely, I'm going to split it into its two answers. We are going to get one where we add and one where we subtract. So I'm going to get x cubed equals 18 plus the square root of 272 divided by 2. And then x cubed equals 18 minus the square root of 272 divided by 2. Okay, so from here, I do need to calculate, and I'm going to do it on my calculator. So I'm going to do 18. Let's see if I can get both parts on here. There we go. So 18 plus the square root of 272. And then you need to hit equals before you divide. Otherwise, it only divides the 272, the square root of 272 by 2. And I want it to be the whole thing. So you want to make sure you hit equals. Other option is you put a bracket around the entire numerator on your calculator. It's easier just to hit equals. And now I can't remember if I did or not, so I'm going to do it again. So 18 plus the square root of 272. I did not. So I hit equals, and then I divide by 2. And I get approximately 17.25. But I need to pause here and ask myself, is that my final answer? And that is unfortunately not my final answer because we are not solving for x this time. We are solving for x cubed, and there will still be one step left to go in order to solve. So since this is not my final answer, I'm going to write the entire thing down. I don't love decimals, but I'm going to do it. Okay, and then to get just x, I need to find a way to get rid of that cube, and I would do that by taking the cube root of both sides. So on my calculator, I'm going to do the cube root. You should be able to do cube roots using the second function of your exponent button. So I got approximately 2.58, and then the next number is a 3, which is going to leave that at 2.58. So on this one, x is approximately equal to 2.58. Okay, so then we have to do it one more time, but this time with the subtract. So I'm going to do the same thing I did last time. I'm going to work this out on my calculator. So I'm going to do 18 minus the square root of 272. Please hit equals and then divide by 2. And I got this number here, 0.753788748. So I want to write the whole thing down because this is not my final answer, and we do not round until our final answer. If I were to round now and then do another calculation and then round that answer, it makes your answer very inaccurate. And it might not seem like such a big deal right now, but you know, if you go on and take physics and you're building bridges or planning space shuttles, you don't want to be using values that are really rounded and not very accurate, right? Sometimes it really matters whether your number is accurate or not. All right, so I'm going to take the cube root of both sides. So that's my exponent button. I'm going to use the second function of that. And I got approximately 0.9100 or 0.91. So those are my two solutions. Okay, you can join me in the next video to learn about how to solve by factoring.